Today we are going to start with some useful stuff for business students. We call it linear programming problem. What is the linear programming problem? Linear programming problem, you would like to minimize a linear function. Okay. So this linear function you would like to minimize or maximize also linear function. Up to what? Yes, up to some constraint or condition. You can call it condition. So what these constraints will be linear inequality. So we have to know how to graph the linear inequality, and then what happened? The minimum and maximum happen in the corner of these feasible sets, as they call it. So when this linear inequality, you graph it, maybe you have closed set like this one. This is, they call it feasible set. Or the solution set, I would like to say it called solution set. So you have the corners here, the intersection points of these all lines. Okay, and you make a table. You put the value of x, and you put your function you would like to maximize or minimize. Okay, so you put x and y. So this is the corners, and you find the values of the function at these corners. If you would like to have them minimized, you get the corner where the smallest value, right? Of course, don't take 0 and 0. This is not included in your minimization or maximization, right? Okay. Let's start how to graph linear inequalities. Okay. If I'm asking you, what is a linear? This is a linear equation we studied before. This is in this form of a linear equation. To graph this one, you need 2 points. The easy way to get the 2 points, you put x equal to 0 and you get y, and you put y equal to 0 and you get x. So you have this 2 points, 0 and 2, 3 and 0. You put your x-axis and y-axis, scale x and scale y up to the value of x and y. And you can link these 2 points together, so you have this line. If I'm telling you, what about if I don't like this line, I would like to have 2x plus 3y less than 6, not equal. So you are going to take the area down the line or above the line. The easy way, this is the point down the line. So I know this point is 0 and 0. Okay. If I put x equal to 0 and 0, yes, I have 0 plus 0 less than 6. Yes, it is okay. So yes, I check with one value down the line and I find it's okay. So this shaded area, okay, is not the line. It is 2x plus 3y less than 6. So this is the area. Okay, of the linear inequality, right? Be careful, the line is not included because you have only less than, right? You don't have equal. If you have equal, I have to make the green line as a red as well, right? This is how to graph the linear inequality. Let's have another one. If I am asking you to graph x less than -1, so it is easy. I have x-axis, y-axis. I know x equal to -1 is a vertical line or horizontal line. Yes, vertical line. Vertical line. Fine. So I come to -1 here, and I make a vertical line. So this is exactly x equal to -1. But he's not looking for x equal to -1, x less than or equal to -1. So shall I take the right hand side of the line or the left hand side? To the right hand side, I have 0 x. If I put 0, so I have 0 less than, yes, less than or equal to -1 is correct. So I'll take the side where this checkpoint is correct. So yes, I make the line as the same color as the shading color because I have equal. Okay, let's have another one. Graph x minus 2y greater than 0. How to graph this one? Also, I cannot graph the inequality. I have to make it as equality equation. So I have it like this. Now move this one to the other side. I will have x equal to 2y. If I divide it by 2, I have half x equal to y. This is the line equation. I need 2 points to graph this one. Okay, so the easy way, you put x equal to 0, so you have y equal to 0. Now it is easy to have x equal to 2 to have y equal to 1. Now I have 2 points. I can grab this one, scale my x-axis. The maximum value is 2, so I have enough space to make it 1 by 1. Y 0 and 1. Where is my 2 point? 0 and 0. This is a 0 and 0. Where is the other point? 2 and 1, 2, and I take 1. This is a 2 and 1. And this is 0 and 0. Okay, now I link this 2 points together and I can extend it. Now I would like to check how to graph this one. Yes, you cannot use 0 and 0 to check at this one, but choose another point above this one. This is a point here. X equal to what? 0 and y equal to what? 1. If I put x equal to 0 and y equal to 1, do you think 1 is greater than 0? Yes. Because y is 0. No, y is 1, sorry. Y is 1, x is 0, so I have 0 minus 2. Do you think minus 2 is bigger than 0? No. So I cannot count this side because it's false. Give me something impossible, right? So I'll get down the line. But I am not going to include the line because I don't have equal. So I'm just shading the area down. So this area is exactly x minus 2y bigger than 0. So you can use any point above the line or down the line to check it. Okay. If it is impossible, don't take this area, including this point. If it's satisfied, yes, you take that. If you have greater than or less than without equal, don't include the line with you, right? Let's have another one. Now I'm just asking you to graph two inequality. Graph 4x plus 3y and x minus y less than 0, and this is greater than or equal to 12. Now, to graph this one, I have to write the inequality corresponding to this two. I have 4x plus 3y equal to 12. I know this is line equation. I need 2 points, x and y. The easy point to put is 0. So you have y equal to 4. And when you put y equal to 0, you have x equal to 3. That's enough for this one? Okay. Let's graph it. Yes, let's graph it. X. Now we are revising the line equation as well, right? So I can scale x and y. X maximum is 3, so I have 1, 2, 3, and y is 4. 1, 2, 3, and 4. Okay, now the 2 point 0 and 4 and 3 and 0. So 0 and 4, this is 0 and y is 4. This is the point 0 and 4. And 3 and 0, this is the point 3 and 0. Now I just link these two together. Okay. Now I would like to check, do I will take the point down the line or above the line? I can check by 0 and 0. If I put 0 and 0, if I put 0 and 0, I have 0 plus 0 greater than 12. No, this is impossible. This is impossible. Because this is impossible, so I cannot take the point with 0 and 0. I check with 0 and 0, right? So I will take the other side. So take the other side and including the same line, right? So I'll take this one, this side. And also I have to include the line. Okay, I have to include my line. So I have to make it black, similar to the shading. Okay, now I know this area to the right hand side is 4x plus 3y greater than 12. Okay, let's go for the second line or the second inequality. X minus y equal to 0. This is very simple one, y equal to x. This is a line passing through the origin, because if I put 0, I will have 0 for y. Take 1 and 1, okay? So this is the point, and 1 and 1 is here. So this is 1 and 1. And this is 0 and 0. Now I'm going to link this two together with color, blue color. Okay, now I'll take the area down this blue line, y equal to x, or below this line. I can't take any point. I'll take this point, right? This point is what? X equal to 1 and y equal to 0. If I put x equal to 1 and y equal to 0 in x minus y less than or equal to 0, x is 1 minus 0 is 1. Do you think 1 is less than 0? Do you think so? Of course not. Impossible. So I cannot take this area, including this point I check with. So I'll take above this one, okay? So I'll take the area above. My line is included? Yes, is included. So what is the feasible set? The feasible set is the set including the two colors. I have the old one is black, and I have the blue. So the feasible set had a corner. This is the corner, and this is area here, right? Okay. So this is a feasible set. It is open from the above one. So you cannot find the upper limit. You have only lower limit. The intersection. Let's go and have more than 2. Okay. I'm asking you to graph. X greater than or equal to 0. Sorry. Y greater than or equal to 0. And x plus y minus 6 less than or equal to 0. And 2x plus y minus 8 less than or equal to 0. Okay, how to solve this one? Easy one. X equal to 0. This is the y-axis. So I have nothing to do with this. Y equal to 0 is x-axis. So I have a positive x-axis and positive y-axis. So when I'm going to graph, no need to have a negative value, right? So I can start from the positive for both sides. No need to ask my paper to have a negative, right? Now let's go for the next one. X plus y minus 6 equal to 0. I need 2 points to graph this one. X and y. Yes, put x equal to 0. When you put x equal to 0, you have y minus 6 equal to 0. So y equal to 6. Okay. Now put y equal to 0. You have, yes, you have x plus 0 minus 6 equal to 0. Move this one to the other side, so x will be equal to 6. Okay. Now I can grab this one. I don't have enough space to scale this one. I can scale it 2, 4, 6. No need to make it 1 by 1 if you don't have enough space. Also, I can have it 2, 4, 6, 8. Let's fix this 2 points. So I have the 2 points. This is give me what? 0 and 6 and 6 and 0. Now how to fix this point? 0 and 6. This is a point. 0 and 6. 6 and 0. Now I'm just linking this together because I have equal, so I'll make the line with the same color. I'll choose a nice one now. Take the green one. Okay. Shall I take the area down the line or above the line? I have to check with a point. This is the easy point, 0 and 0. If I put x equal to 0 and y equal to 0 in this inequality, x plus y minus 6 less than or equal to 0. If I put 0, so I have minus 6 less than 0. Yes. Okay. So because I have equal, so I have to take it with the same color. Let's go for the other line, which is this one. Now I have x, 2x plus y minus 8 equal to 0. Yes, I can take 2 points, x and y. If I put x equal to 0, I have y equal to what? Y equal to 8, yes. If I put y equal to 0, I have x equal to 4. So I have these 2 points, 0 and 8, and 4 and 0. So 0 and 8, this is a point, 0 and 8. The other point, 4 and 0, this is 4 and 0. Now I just link these two points together to have the blue line. Oh, sorry. Now I would like to check, shall I take the area down the line or above the line? Okay, let's check with 0 and 0, which is the easy one to check with. If I have 0 and 0, give me 2x plus y minus 8 less than 0. If I check 0 and 0, so if a minus 8 is less than or equal to 0, yes, it is okay. So okay. So I'll take the area including 0 and 0. Now I have x equal to 0. This is the y-axis. And y equal to 0. This is the x-axis. I know this one from the beginning. So yes, so I have this one. And also that one. So what is the corners here? Yes, the corners including everything. So I have all the x and all the y. Okay, and the whole y. So the space having all the colors is the feasible set or the solution set. So yes, I have this one. This is the corners here. Okay, I know this point 4 and 0, right? I know this point 4 and 0. I know this point, which is 6, 0 and 6, right? But I don't know this point. This point is the intersection point of the two lines. Okay, catch it? How to find the intersection point of these two lines? As simple as that. Use your calculator, please. Using calculator. You go for mode, go for equation, go for ax plus by plus c equal to 0. Do you have this one? Guys, the formula in your calculator, ax plus by equal to c or plus c equal to 0?
Plus c equal to 0.
Excellent. So this is ready to use with equal with your calculator, right? Now input the coefficient. What is the coefficient? The first one, 1, 1 minus 6. And the second one, 2, 1 minus 8. Press equal. What do you have now? X equal to what? Mode, equation, choose ax plus by plus c equal to, sorry?
Minus 2.
Minus 2. And y, go down
Minus.
by the key. Y equal to what?
Doctor, should 2 and 4, yes? I think it's 2 and...
Yes, yes, 2
But
and
in
4, yes.
calculator, minus 2 and minus 4, why?
It is 8.
Ah, okay.
It's 8.
Okay.
So you have minus 2 and 8?
Doctor, it's mode 5.
No, should it be like this one? Should it be minus 2? You are in the positive side. This is why I catch your solution is wrong.
Doctor, should we press mode 5, then what?
Mode, equation.
Yeah. Then which one, Doctor?
Mode, equation, and input the type of your equation is ax plus by plus c equal to 0. Choose it. It's asking you to input the coefficient. The coefficient of the first one is 1, 1 minus 6. After each one, you press equal to jump to the next. The coefficient of the second equation is 2, 1 minus 8. Once you press equal, you give you what? X equal to what?
Doctor, we don't have in calculator a plus b plus c equal to 0. We have
what do you have it? You have ax plus by equal to c, right?
Yes.
Yeah, this is why what I'm asking you, right? Ax plus by equal to c. So this one is not fit for your calculator. So first you have to write it as it is, equal to 6. Okay, for this one, you make it like that. And the other one, what is the first one? 2x, yes, equal to 8. So yes, you can go for this one like that.
2 and 4.
2 and 4, yes. So you can go for this is 2 and 4. Okay. This is how to solve this one together. Okay. Now, if you are ready to graph this one, you can graph it by Desmos as well, right? If I'm just saying x bigger than or equal 0, he gave me this side, right? Y bigger than or equal to 0, he gave me that side, okay? Now, x plus y less than or equal to 6, yes? Minus 6 less than 0. Minus 6 less than 0, okay? Yes. The last inequality, 2x plus y minus 8 less than or equal to 0, okay? Now this one also would equal. Where is the corners here? Yes, this is one of the point, okay? And this is a corner. This is a corner here. Look at this, your intersection point, yes. Now I can do it by Desmos and I can do it by hand, right? So this is the way of graphing the system of linear inequality. So you just exactly like graphing system of linear equation, but the difference you just decided to get the area below or above the line. Okay. Now let's go for how to find the maximum or the minimum, as we said in the corner. Look at this one. He already graphed it for you, right? He graphed it for you, and he would like you to do what? To find the maximum or minimum values, right? So let's go and do it one by one. Let's do this one, okay? Once you graph the linear inequality and you have the feasible set at this one, S here, okay? You do a table with X and Y, and then you have to find the minimum value of the function given to you. In this case, it gives you the function Z equal to 2x plus 3y, 2x plus 3y. Now, the first point, 1 and 1. The second point, 8 and 5. The third point, 4 and 9. The last one, 2 and 8. You just substitute here by x equal 2, so z here will equal to what? 2, x is 1, y is 1. So you end up with 5. Let's go for here. Z will equal 2, x is 8, y is 5. So 2 times 8 is 16, 3 times 5 is 15, so you end up with 31. Z in this case, x is 4, y is 9, so 2 times 4 is 8, 3 times 9 27, 8 plus 27 is 35. The last value of z at the point x equal to 2 and y equal to 8, 2 times 2x, 3 times y, which is 8, 2 times 2 is 4, 3 times 8 is 24, 24 plus 4 is 28. So the maximum z equal to what? The maximum z equal to what? What is the maximum value here? 35? Is it?
Yeah, Doctor.
Yeah, 35. This occurs where? At x equal to what? 4 and y equal to 9. Okay. What about the minimum? The minimum z equal to what?
5.
5, yes. 5 occurs at what? X equal to 1 and y equal to 1. This is what they call it, the corner theorem. This is, we call it the corner theorem. So the corner theorem saying the maximum minimum occurs at the corners, right? Okay, we have done this one. Let's go for the next one. Number 2. Again, I'll make a table. This is X, this is Y, this is my Z, given to me 3X minus Y. Okay. The first point is 2 and 2. The second point is 2 and 6. The third point is 7 and 9. And the last one, 10 and 1. 10 and 1. Now let's substitute here to see what is the value of Z in the first one. 3, X is 2, I'm substituted by 2, minus Y is 2. So I have what? 4? Yes, 4. Now the second value at the second point, Z equal to 3, X is 2, minus Y is 6. So I have 0. Okay. Next, 3, X is 7, minus Y is 9, equal to what? 21 minus 9, 12. Excellent. Now I'll go for the last one. 3x, x is 10, minus y, which is 1. So 3 times 10 is 30, minus 1, 20. Now, the maximum z equal to what? 29? Yes. At x equal to 10 and y equal to 1. Yes. What about the minimum?
0.
Minimum z equal to 0. This happened at what? At x equal to 2 and y equal to 6. Very good. Let's go for number 3. He graphed for me the constraints or inequality, and he would like me to find the maximum and minimum, right? So I'll have the corners, and my z in this case is 3x plus 4y. The first point is, I take it as 9, 0. The second point is 4 and 6. The third one, 3 and 10. And the last one, 0 and 20. If you substitute by, so that will be 3 times x is 9, y is 0, so you end up with 27. Now, let's go for the second point. Z will equal to 3, x is 4, plus 4 times y, 6. So 3 times 4 is 12, 4 times 6, 24, so I have 36. Now, z will equal to 3, x is 3, plus 4y, y is 10, so I have 40 plus 9 and 49. Okay. Now, the last one. Yes, z will equal 3, x is 0, plus 4 times y is 20, so I end up with 80. Okay. What is the maximum value? What is the minimum value?
Maximum is 80 and minimum 27.
Let's go for the minimum first. Minimum of z equal to what?
27.
27 at x equal to what? 9 and
0.
y equal to 0. What is the maximum value you said?
80.
No, sorry. Undefined. Why it is undefined? Because your area is not bounded above, right? You have no limit above, right? Catch it? So it's very important to remember, when you have lower bound, you have a minimum. If you have like this one, you have bounded lower bound and upper bound, so you can find a minimum and maximum. But when you have only lower bound, you have a minimum. Catch my point? So be very careful with the minimum and maximum when you have open area like this one. If it is open from the above, you have no maximum. If it is open from down, you have no minimum, right? Okay. Now let's solve only one of these ones, right? Now we have to graph and find the values at the corners. Choose one to solve it for you, and I'll leave the rest for you. Which one you would like me to solve it? Guys? Go for 17?
Okay.
Okay. 17 is asking you to minimize, yes. C, which is 3x plus 6y, subject to, this is a condition, or the constraint they call it. The linear inequality, x plus 2y bigger than or equal to 40.
Doctor.
Yes.
You are not sharing.
Okay, I will share it, but after I write the question, because okay. X plus y greater than 30, x greater than 0, and y greater than 0. Okay, so this is the 17. Let's go and solve it. The first step, you have to graph the constraints, this one. Okay, and then make the table to find the minimum or maximum, right? So how to graph this one? I have to convert it into a linear equation. So I have to graph x plus 2y equal to 40. I need 2 points. The easy one is to put x equal to 0. I have y equal to 20. If I put y equal to 0, I have x equal to 40. This is the first one. The second one, x plus y equal to 30. I need also 2 points. The easy one to do, x but equal to 0, y is 30. From but y equal to 0, I have also 30 for x. Okay. I finished the main point, and I know x equal to 0 is the first quadrant, okay, and the third quadrant. So this is y-axis. Y equal to 0 is the x-axis. Because I have x positive and y positive, so I'm only in the first quadrant. This is mean first quadrant. First quadrant. أو الربع الأول بالعربي. First quadrant. Okay. Let's graph it. Yes, let's graph it. I'm working in the first quadrant, so no need to ask my paper to have a negative value. Right. Yes, I cannot scale x 1 by 1 because I don't have enough space. So I can make it 10, 20, 30, and 40. And also X 10th, it's okay. 10, 20, 30, and 40. Let's go for these 2 points in the yellow line. This 2 point, 0 and 20, and the other point is 40 and 0. 0 and 20, this is 0, this is Y, this is the point 0 and 20. And the other point, 40 and 0, this is the point 40 and 0. Okay, I just link these two together with the blue color. Okay, now I'll go for the green one. The 2 points are 0 and 30, and the other point is 30 and 0. So 0 and 30, this is the point. 30 and 0, this is the point. Okay, now I link the two green points to have the green line. Okay, why I don't go and exceed the negative values of for X and Y? Because I have this one, X positive, Y positive, I have only first quadrant, right? So I have to get the intersection point here. How to find this intersection point? I have to solve the two equation. What is the two equation? X plus 2y equal to 40. And the other one, X plus y equal to 30. Yes, they are ready for the calculator. Go for mode, equation. Choose ax plus by equal to c. Input the coefficient. What is the coefficient? Yes, the coefficient is 1 equal, 2 equal, and 40 equal. Go for the next line. So 1 equal, 1 equal, 30 equal. If you press equal, what do you have? X equal to what?
20. Doctor.
Sorry?
20.
20. And y equal to what?
10.
10. Brilliant. So my sketch is okay. So this is the intersection point. I did it by the calculator. What is my feasible set? My feasible set is the one included with this area. This is my feasible set. So in this case, I have minimum and maximum, right? He's asking for the minimize. So equal to what? I have to have, I cannot get it like this. I have to make a table, right? Okay, let's do the table over here. This is my Z. And this is Y, this is X. How many points I have? Don't take 0 and 0, no need to take 0 and 0. So you have 30 and 0. And the other point is? The other point, which the intersection point, 20 and 10. And this one, 0 and 20. Now let's have the value of Z in this one. So I just substitute by X equal to 30 and Y equal to 0. So I end up with 90. Let's have the value here. Z will equal to 3 times X. X is 20 plus 6 times Y is 10. So I will have 60 plus 60, 120. the last value of z, 3x is 0 plus 6 times y is 20. So I have 120. What is the minimum value of this one? So minimize z equal to what?
90.
What? 90? Yes. 90 at x equal to what?
30 and y equals
30 and y equal to what? 0, right? Catch it? Easy? I finish my turn. I stop recording and I'll give you the turn, right? This is the linear programming problem.